a non-for-profit organisation called the IHSDO, which stands for the International Healthcare Terminology Standards Development Organisation, which nobody could remember and nobody could pronounce. So about 3 or 4 years ago, we changed kind of the working name to SNOMED International, which people can remember and can say. So we set up the organisation back in 2007. It was set up as a not-for-profit and for public good. Initially, there are 8 member countries. That's grown over time, as I'll show you in a moment. But then, like I said, we adopted in 2017 the trading name for SNOMED International, just because it was easier to remember in some ways. Things move very quickly. So who's involved now? It was 48, and from the start of this week, it's now 49. Because this week Hungary have joined as a member. So if you look at the map, all the darker blues are SNOMED International countries. So the way we license SNOMED, essentially countries join, pay a membership fee nationally, and then anybody can use SNOMED for any purpose within that country. So all the dark blue bits are SNOMED International countries. The light blue bits are non-member countries, but countries where SNOMED is used. So as you can see, we've got a fair footprint across the globe, I guess. If you want to know the countries, then they're up on the screen there. Obviously, the Americas, Asia Pacific, I would say this because I'm the middle bit. So the Europe, Middle East and Africa, we're up to now 22 countries in the EU, with Italy doing a national pilot, which would be 23. Of the other 4 countries, 2 I'm working with to become members very shortly, and 2 are a bit of a longer term work in progress, if you like. So we're kind of getting to the stage within the EU now where we can certainly look to use more of SNOMED in terms of EU specifications, EU standards, and a lot of the EU projects, particularly with cross-border work and the European health data space. So what's the vision of SNOMED? So because we've grown in some ways, the aim is by 2025 that clinical terminologies will be used globally, and this will result in better health and improved patient outcomes, and all that will be supported by one language of health, which will be underpinned by SNOMED CT. The one thing I will say about that statement, that doesn't mean that we're looking at the only terminology by 2025 in the world will be SNOMED CT. That isn't what that statement means. But it does mean that SNOMED CT will form the common link, if you like, between a lot of other classifications and terminologies. So why SNOMED CT?
And I'll take over from here. Thank you. Thank you, Ian. Yeah, so that was the background and information about the organization. So let's now dive into the objectives and design criteria for SNOMED. So as Ian was just saying, SNOMED CT is designed to support the improvement of patient outcomes and better health. And correctly, it's not the intent that SNOMED CT is the only terminology, which is also why we say that clinical terminologies will be used. But in order for these terminologies to work together, we need to have a common point of reference, and this is really where SNOMED CT plays an important role as well. But as we'll see throughout the day, SNOMED CT has a range of clinical benefits. So with the focus today being on the clinical side, we really want to focus on how can we obtain some and utilize SNOMED CT to actually improve the way clinicians work and use clinical data. One of the attempts of SNOMED CT is to support high quality clinical data. And what are the measures for data quality? There's a range of ways that you can measure clinical data quality. Some of them are, as you see them here, accuracy, consistency, completeness, and timeliness. So this is not an exhaustive list. There are other measures as well. But SNOMED CT really support these four heuristics. So accuracy, which says something about how well the information reflect reality. Accuracy is about being able to record the details and not only the high categories, but actually being able to accurately describe what happened. Consistency is to make sure that when something happens, it's represented in the same way every time, so that we don't. When you'd use free text, you would just write something, a broken ankle, and next time you may write that the ankle has been fractured. You would use different terms. So you wouldn't use a consistent natural language if you use free text. But when it comes to data processing, we need a way to obtain some consistency so that we can process it afterwards. Completeness is around whether the information captures the whole picture. In order to make clinical decisions, you need to have the full overview of the clinical situation so that you can make the correct decisions and the best way forward for the patient. And that also requires the timeliness of data and timeliness of information, that you can acquire the information you need when you need it. So this is the basis for what we try to do with SNOMED CT, to support high quality clinical data and support these measures. And we do that by focusing on how SNOMED CT can support interoperability, support the meaningfulness of the clinical records, and the actionability of the data. So some of you may have seen these slides before, but I'll just run through it because it provides quite a good background for why it's important to have a common language of health. If you work at clinical organizations, hospitals or departments, clinics, you know that an immense amount of data is recorded and captured in the clinical information systems that are implemented in the organizations. And all this information is captured with the overall objective to support the clinicians in delivering the best possible service and make any relevant enhancements to the services. And a prerequisite from a clinical point of view is that they have the information readily available and easy to understand, both for the humans and more for the machines as well. So imagine that you have at these various sites patients coming in with the same disorder. In this example, it's an intervertebral disc prolapse. And information is captured in each of these sites about this diagnosis. Well, each of the systems in these hospitals or clinics may use different terms in the user interface. So clinicians, they can understand these terms and they will use that either via free text or maybe via some structured input. In the database, this information may be captured again as free text or sometimes as structured codes. This is an example of how each system uses different codes in the storage level. So this is an illustration of what really happens out there. The fact that the IT systems that are used, they don't speak the same language. And you can even argue that they don't have the same alphabet. They use different codes, different representations to represent the meanings. And you can say, well, we use IT, that makes us happy. We have captured information, we have stored information. In essence, we should be able to process it. But having this diverse and heterogeneous way of representing information is really a painful thing when it comes to reuse of data. So imagine that you want to, for example, count all the situations where in a country or in a hospital even, where you want to count how many intervertebral disc prolapse happened this year. So in this situation, in order to gather the information from all the organizations, it's really difficult to be specific about what are the codes to include. And it's also very difficult to be assured that you have all the information you need did we really capture all the different instances of intravertebral disc prolapses? Another example is if you want to count not only the intravertebral disc prolapse, but any kind of back injury that happened. How would you then do that? Well, then you need to go into all the systems, make sure that all the codes and all the various representations of intravertebral disc prolapse were extracted in all the various ways that these are captured in each of the systems. So you can see how this will be an explosion of and a very comprehensive task just to answer a very simple question. Another example is if you want to transfer a patient from one organization to another, and you also want to transfer the health record. So again, even though it's IT and we may be able to send it via an email, in the receiving system, the information is not processable with the information that you have there. The receiving system would not be able to understand that the IVDP means exactly the same as prolapsed intravertebral disc that is used in the receiving system. And at the database level, you would not be able to know that PID 001 is the same as the IVDP used in the receiving system. And the clinicians at the human side would also maybe struggle to understand whether IVDP is exactly the same as they use in the receiving system, where they used a more extended version of the same term. So the solution to this mess and chaos of data is to standardize and use a common language across each of these systems. And such a common language should really focus on representing the meanings. So what happened? So this is illustrated by the picture in the middle. It's just a thing. It doesn't necessarily have one term. It's just a thing, that the occurrence, the clinical idea that happened, an introverted disc prolapse in this case. And these clinical ideas are represented in SNOMED CT by unique identifiers. And we also support the fact that you can use whatever term you want to represent this clinical meaning. So at the database level, we represent the unique concept identifier to represent the clinical idea, and we allow for different terms to be used in the user interface to support clinical acceptance and acceptability and any language preferences that there may be. Because we acknowledge that the language used are different across countries, and even within the same countries, different preferences may also occur. So these are the basic design features of SNOMED CT, representing clinical meanings uniquely, allowing them to be captured in a human-friendly way and stored in a computer processable manner. SNOMED CT is a terminology for clinicians, so that clinicians can have a very even though they use a terminology, a natural way of using the clinical spoken language while they record clinical data and while they do it in a structured manner, but also to be able to support other stakeholders that are equally important for the efficiency of the whole healthcare ecosystem, such as the hospital administration, analysts, and research. So all of these stakeholders contribute to improve the healthcare environment. And of course, clinicians are the point of departure for clinical data capture, but we also need to consider that these other stakeholders have requirements for clinical data. Let's start where the data is spawned, at the clinical sites. So clinicians want to be able to record a clinical focus using a clinically focused language, want the data to be available at the right time in the right place, and want documentation to be fast, easy, and accurate, and support clinical research and decision making. We'll dive into these requirements in the next presentations, so I'll speak very briefly about this because this is essentially what we're focusing on today. How can SNOMED CT support these requirements? And the short version is, well, SNOMED CT is designed not with a specific perspective. It's designed to support whatever clinician we are meeting in the clinical journey, whether it's in the emergency room, the laboratory, the people doing care and treatments or surgery or rehabilitations. It's also not isolated to one type of professions. It covers the various professions also involved in and around the patient. So SNOMED CT is broad in the sense that it spans the whole journey and it spans all of the clinical professions. When clinicians use SNOMED CT, they use it via a user interface, the electronic health record. And when using SNOMED, the intent is that the clinician shouldn't even know that they are using a structured clinical terminology. So in the user interface, they won't see any codes. They just see the clinical terms that are familiar to them. Behind the scenes, when they use a terminology such as SNOMED, they get a huge knowledge resource included. So here in this situation where you have captured the concept pneumonia, what is provided is the whole semantic network of SNOMED CT, because in SNOMED CT, the concept pneumonia is defined as being a type of lung disorder, which is a type of disease, having a finding site of lung structure, which is again a type of body structure, having an associated morphology of inflammation and consolidation. So in the clinical user interface, you just capture the fact that the patient has pneumonia. The system, with that information, the system knows that pneumonia has all of these characteristics, that it's a lung structure, which is a body structure, and it's a lung disorder, and it is a type of inflammation and consolidation. So all of this is implied by just capturing one single concept, because what you get with SNOMED CT is a big network of clinical meanings that are associated to each other via semantic relationships. And the clinicians shouldn't bother about that. They should just feel assured that because we have SNOMED CT implemented, this gives me some opportunity as a clinician to utilize data better, which you will see throughout the day-to-day. But for one, it's to support this network will support the accurate and consistent recording of information, and it will provide some flexible retrieval and opportunities for reuse of clinical information, which will benefit the other stakeholders that are important: administration, analysts, and research. For hospital administrators, their requirements are what you see here. Well, important for them to ensure that all the services are delivered, recorded, and reimbursed, so that they can keep track of what has been done, and making sure and also support the ongoing planning. It's important to them to be effective, so wanting to minimize data redundancy and data redundancy occurs in several places if the same information is collected in different systems to support different purposes. So therefore, it has for many years been an objective to try to reuse data in the best possible way, so that clinical information captured at the point of care is the basis for secondary purposes. And that's the overall vision, because that will make a more effective healthcare system, because the clinicians won't have to document multiple times, but it will also improve the data quality, because there's evidence for this, that when clinicians record once and it's reused, the accuracy is increased compared to if the same information is captured in multiple places. There will be some alterations of the meaning when it's captured in multiple systems. So although it was supposed to be the same meaning that is recorded, there will be some alterations. So the ideal scenario is that the information recorded at the point of care, being it information about the patient history, tests and investigations, diagnosis, procedures, medication, a range of other information, could be represented by one single code system and used by administrators to extract, for example, for reimbursements, for audits, for other types of administrative purposes. And in this case, using one code system is very attractive, because then you wouldn't have to understand how, if you were using 10 different code systems for these purposes, you would need 10 different ways of making sure you make the right aggregations. So using a single code system make it efficient to do the aggregations you need. And the picture is quite the same for analysts. Again, they want to be able to collate data, maybe have ways to perform analysis and provide insights on a whole population, to be able to measure the frequency of diseases and causes of death and or mortality and morbidity statistics in a country. So for a hospital and a hospital information manager or administrator, as we looked at before, it was of course on that set of hospitals or clinics involved there. But for an analyst, it's often about collating data from multiple sites. So you can imagine having a data warehouse or register that is using SNOMED CT, and then the different sites report information into such a register. And the register will then support the information analyst to do selective and explorative analysis of data. You'll see later the ways that SNOMED CT support a very advanced way of doing data analytics. But with this setup, you can also use maps to other coding systems. I've just illustrated it here with ICD, but there could be other classifications or local coding systems that are used nationally for reporting and statistics, and that support the statistical analysis of data. And SNOMED CT comes with a standardized representation of maps between SNOMED CT and other code systems, so they can easily be applied. The point here is that at the point of care, information is captured with SNOMED CT, and that leads to the possibility for SNOMED CT to be a hub to other code systems. Think about the vision that Ian was talking about, that the vision is that clinical terminologies will be used, and clinical terminologies should be used for the purpose they were designed to be used. And SNOMED CT is designed to be the foundation, a core reference terminology that can provide as an efficient hub to other terminologies as well. Looking at researchers, having the requirements to be able to identify it, for example, clinical trial candidates, and be able to collate and analyze data from various sites, and be able to query data to be able to identify important patterns in data that can be used for policy, decision making, maybe to create new evidence. And the picture is the same as we saw before, where you can collate information and report it to research data store, and that will give you a collated picture of a large set of patients. It will, using a common code system, will allow you to collate across not only a single country, it could also be across countries, it can be across regions. So you are able to get a much larger data set for your research studies. So these examples show how data collected at the point of care will be the basis for the secondary uses and will all feed into the whole set of requirements that exist to make an efficient healthcare sector. So the principle is that data is collected once, but it's used many times. Moving on to the meaningfulness and to how the design of SNOMED CT supports the meaningful representation of clinical data. So a clinician has gone to medical school and has a huge clinical knowledge. So when they see a term such as heart attack, myocardial infarction, cardiac infarction, and other terms, they would have an understanding of what that means. They would understand that a heart attack or a myocardial infarct is a type of ischemic heart disease. It involves a necrosis of the heart and tissue death located in the myocardium structure. So the human brain, with the medical knowledge, would have that understanding. And in health sector, where we rely very much on computers and processing, well, then we need a way to make the computers have a somewhat similar interpretation. And that's also an important role in the design of SNOMED CT, is the computer processability and being able to facilitate and support the emerging requirements for health IT. So computers by themselves does not just know these things and have this medical knowledge. So SNOMED CT uses the semantic network that I was illustrating before to represent that knowledge. So these relationships, these links that we saw before with pneumonia, all concepts in SNOMED CT are defined, representing what is meant by this concept. So the clinical idea of a heart attack is that it is a type of myocardial necrosis, it is a type of ischemic heart disease, it has a finding site of myocardium structure, and it has an associated morphology of infarct. So the type of relationship between two concepts is also defined so that you know what the relationship semantically means. So whether it's a site, whether it's a morphology, whether it's a subtype relationship, that's very important to be able to understand what is meant by the relationship. And it's important for the computers to be able to process. If you ask the computer what is the finding site of a heart attack, it would be able to respond. So these relationships and this way that SNOMED CT comes with a definition for each of the concepts is really the power of SNOMED. Here's another example using a procedure where you have a laryngoscopy, or what you could also say an endoscopic exploration of the larynx, an endoscopy of larynx. So there are different terms that can be used to represent a single procedure. But again, the defining properties for the laryngoscopy is, as you see them here, it's a type of examination of larynx, it is a type of endoscopy, it uses a method of inspection, it has a procedure site direct of laryngeal structure, it uses the device of a how would you say that, Ian? Laryngoscope. Sorry for the pronunciation. So this just shows that depending on whether you have a clinical finding or a disorder, as we saw before, or in this case, a procedure, the different relationships that are used are different. They have a meaning that fits to whether it's a procedure or a finding. And these relationships are useful because they enable searches and they actually support the accuracy when describing the situation. So although you don't just record a single concept, all the accuracy is implied by the definition of that concept. And we'll look at later the analytics features and the decision support features. And let's just have a look at those ISA relationships. They are special. They build the SNOMED CT hierarchies. So a laryngoscopy is a type of endoscopy, while the myocardial infarction is a type of ischemic heart disease. Endoscopy is a type of inspection. Inspection is a type of procedure. So these ISA hierarchies forms a hierarchical structure. And there's not only one way up to the procedure through the hierarchy. There are many branches potentially. But what this means is also that if you want to ask, is a laryngoscopy a procedure? Well, yes, it is, because it's a subtype of the concept procedure. So we say that these relationships are transitive, meaning that if an endoscopy is a type of inspection, it also means that laryngoscopy is a type of inspection. And the same goes with the heart disease or the myocardial infarction, which is an ischemic heart disease, which is again a heart disease, which is a disease. So myocardial infarction is a disease. SNOMED CT is not just a code system of diagnosis. It covers a broad scope of the clinical meanings that are relevant to capture in and around a health record. So this slide just illustrates that, as you've seen, procedures are included, clinical findings, disorders are included, but also the observations, devices, body structures, microorganisms, pharmaceutical products, clinical drugs, events. We have a total of 19 top-level hierarchies in SNOMED that includes concepts that span across all the variety of clinical data that you could imagine being relevant to capture. And this is also why we can claim in the first slide that SNOMED CT is the world's most comprehensive clinical terminology. Comprehensive in the fact that it's the only terminology out there that covers the whole span of data that is relevant to capture within a single coding system. This just illustrates how you could look at a concept in our SNOMED CT browser, and you can look at the subtype hierarchy. So each of these 19 top-level hierarchies have a range of concepts that moves from very high level to very detailed. And there's no limit to how detailed it can be. That's the clinical knowledge, that's the clinical meanings that determine how granular you should go. So here you can see that bronchopneumonia is a type of pneumonia, which again is a type of disorder of respiratory system and which is a clinical finding. And you can even see that there are 31 from this version, there are 31 types of bronchopneumonias as well. So there are, and if you go down to the congenital pneumonia, there are 9 different types. So there's no range to how deep you can go. And each of these concepts are uniquely defined and represented in SNOMED CT. Let's dive into the actionability, which makes it really interesting also to work with SNOMED, because this really speaks to why it's important to structure information, because what is it we want to do with all the data that we record? So if we take a look back in history, when people started to document clinical information in their systems, even before electronic health records, people documented on paper. Maybe people still document things on paper at the hospitals. But why do they do that? Well, it is important to document so that you have a way to remember what happened, to be able to monitor the progression of a disease, to share information between your colleagues, and to make sure that you live up to and you comply to any regulations and policies that are specified, so that you live up to all the legal objectives. In the 1970s, and maybe even some places before that, the electronic health records were introduced, providing a more efficient way to document and an accurate way, allowing people to use free text in these systems to record exactly what happened, and with the same objectives as when doing it on paper, but now the idea of interoperability and being able to share information more effectively was really a big thing when electronic health records and the first versions of these were introduced. Then it was also fast realized that it's not enough just to have a single electronic health record. There are also the need for specialized systems for imaging systems, laboratory systems, medication management systems, and so forth. So an electronic health record is not just a single thing. It's a range of systems, modules, and different mini systems that needs to work together to support the optimization of the workflows, to make sure that we can sure to have a high quality of the data and be able to improve on the data quality. And within the specialized each specialized system, there are a higher degree of detail that is required for those specialized systems than maybe in a more broader electronic health record. And the specialized systems also try to introduce more enhanced decision support. So from the millennium and onwards, focus on decision support and how we can get computers to actually help support the documentation process and support the decision-making process has been a big thing. And now, after 2020 or around this time and onwards, the idea of precision medicine and integrating advanced technologies, AI, everything, to have more a personalized medicine is our focus these days. So in future, if you have two patients looking the same, having maybe the same patient history, they may, and the same disease, they may require different treatments. Now we hold down to genes, down to a lot of activities of daily living factors. There's a range of information that needs to be included in when making a decision about what the best treatment for a single patient. So we are working towards a world where the options for treatments and the decisions that needs to be made depends on the individual and not for a person with some certain characteristics. So this evolution of healthcare capture of clinical data has also increased the need for structuring the clinical data. So when it was all paper-based, we have our pen and paper, and that has a huge value at that time. But with these days and with the knowledge we have gained over the past 100 years and more, we have a high need for structured data. Structured data enhances the efficiency in data retrieval and analysis. It supports a more clear communication and collaboration among the variety of healthcare teams. If you think about back in the days, a patient wouldn't see as many clinicians as we do today, and we wouldn't be transmitted across various wards and organizations as we do today. So structured data also supports the evidence-based decision making, that we are able to create evidence, do research to create evidence that will help the decision-making process and also feed into a more personalized healthcare care delivery. Structured data facilitates interoperability and integration, as I've shown you earlier, and it improves the accuracy and consistency and being able to track the patient information over time. So now you are looking at Lego bricks. And why are we doing that? Well, it's just to have you think how information is captured and why it's important to structure. And you can compare clinical notes, free text notes, with this kind of chaos of information. It's very easy to create such a chaos. I have played a lot with Lego, and this is how it looks every time. It takes 5 minutes, and it takes 2 hours to clean up after it. So it's easy to write with pen and paper, just as it's easy to create a big pile of Lego big clutter of Lego bricks, especially when it's disorganized. It's easy to establish, but you will end up in a situation where that each of the bricks and each of the pieces of information is just randomly placed. So it's really difficult to, if you have an unstructured health record on a unstructured system, to know exactly where to write a certain piece of information. Similarly to here, where should I place the small brick? Well, you can just place it anywhere. So as soon as a clinician would see a free text, they can just type in whatever is in the head. Through the years, even the free text-based clinical records have become more structured, so that you can say, well, in this field is where we document the information about the diagnosis. In this field is where we, using free text, documents procedures. So that's a way of structuring it in a bit. But if you just have a blank piece of papers, you will end up in a chaotic situation like this, and it will be very difficult to retrieve information afterwards. You would have to count it all. If you want to figure out how many blue bricks there are in this pile, it will be very difficult. And if you want to then count the ratio of blue compared to yellow, it would require you to count all of these bricks. So what can you do to make it easier? Well, you can start to organize your things. Decide, well, we need a box for all the green bricks. We want to put them here, and we want to divide them into the small and the big ones. Maybe we have different forms. So if we start to organize, we also ask ourselves the question, how do we want to organize? So you make a decision about, okay, this is how we want it, because then it's very easy for us to find all the big green ones or all the small red ones. So a conscious decision is required when you start to organize data like this. You can sort by color, but you may also order by shape. And you may, if you do it by shape, do you then don't care about the color, or how do you want to do it? So that type of organization requires you to make a conscious decision about it. And it has advantages of doing that. Mostly because now you have decided that you are using these bricks, you're starting to structure, you have somewhat a common shape that fit together, so you can start to construct things, and you can easily identify the information that is required to construct, and it's flexible. You can build on top of this. So just as Lego bricks fit together, if you start to structure your clinical data, you can compose things, compose the medical story for the clinical journey in a way that can be, in this case with the bricks, can be viewed, but in the case of information can be processed and understood. So it's scalable, and there's no limit to how much is enough. It depends on the situation. So organizing is doable even with the paper-based records. You can organize things, which makes it easier to find the information you're looking for. You can also start to structure, like we do when electronic health records were introduced. We may have spreadsheets, we may have some forms that at a high level provides the structure, and that will help us do some statistical analysis. Just as you saw with the Lego bricks, find all the red long ones or the green small ones. If you think about Excel sheets, if you have information that is structured, you can filter and you can identify and you can do some statistics on your data. But for going towards precision medicine, and we want to be able to really process, to find new patterns, we want some decision support systems to give us advice about the path forward for specific patients, then it's not enough with the simple structuring. We need some advanced structuring where you are able to make look at the individual and compare with all the other pieces of information to gather a full picture of the clinical situation. So this requires this speaks to the fact that we need something that is more advanced than statistical classifications. We need clinical terminologies. So I want to talk a bit about what the difference is between common, simple structures, such as classification structures, compared to terminology structures, as we have it in SNOMED. Classifications has been used for many, many years to support those secondary purposes that I was talking about before, the management and the statistical purposes, because classifications are designed to summarize data for reporting and statistics. And for each code in a classification, they belong to a single category. So it makes it very easy to identify things, just like the boxes you just saw with the Lego bricks. So you can imagine that you have a box for each of the things and make it easier to identify and count. But it's based on established criteria. So those conscious decisions about how you want to count, they need to be made in advance. For terminologies, they are designed to support clinicians at the point of care enable recording of the relevant clinical data. So no one has decided ahead of the documentation what is relevant and how it's relevant and what the level of detail should be. And there's no decision made about where a certain code belongs. It can be, as you just saw it with the endoscopy and the myocardial infarct, there are multiple supertypes. So we don't define what it is and how it should be counted. We define what it is, but we don't define how it should be counted. And this slide just shows how and why these different types of coding systems have their merit. So at the top we have the clinicians. The objectives are care and treatment. That requires terminologies. SNOMED CT covers a wide range of information, but there are also specialized terminologies such as LOINC, MEDRA, ORPHANET that are specialized within specific domains, but they also have more characteristics of a terminology than a classification. And these terminologies are good for care, treatment, research, but when it comes down to the administrative purpose and management purpose, we require more the capability of doing statistics supported by classifications. Examples of classifications are the family of ICD classifications that are also often useful or a requirement in countries to report using these. But when it comes down to reimbursement, we need maybe even higher and different types of groups, resource groups that are linked to the payment systems. So the further down you go here, the less you have a need for very granular clinical data, and the more you have a need for some specific objectives and conventions for where stuff belongs. Principles for statistical classifications are that they should never organize things into overlapping categories. So there are non-overlapping groups. They are monohierarchical, so nothing can belong to multiple classes, and it's exhaustive. So everything that can be counted should be able to be counted. So let's go, we've looked at Lego bricks. So now let's talk about fruits, because this is not a specific thing for a single classification. This is like general theory on classification systems. So let's imagine that we want to create a classification of fruits. We may have different categories. We want to count the number of citrus fruits, berries, tropical fruits, and nuts. So we create a group for each. So there are none of these fruits that fits into two groups in this case. So it's easy for us to identify citrus fruits, berries, tropical fruits, and nuts. But what happens then if you look at the apple and you don't have a category where an apple really fits? What would you do about it? Because one of the principles of a classification is that it's exhaustive. So anything that can be counted should belong in a group. But apple doesn't really fit in this classification. So what should we do? Well, then what you'll see in classifications is that they have the other category. So because we have an other category, we're able to get rid of everything or place everything in a category. And what you know about the other category is that it's not a citrus, it's not berries, it's not tropical, it's not nuts, it's something else. Another, and this is just another example of a classification. Here we haven't divided it by type, but here we are grouping them by color. So again, this is about the conscious decision about what is it we want to count. So that is determined before you develop your classification. If you're familiar with ICD, it's a classification for diagnosis. It was designed to count mortality and morbidities, or to do statistics on mortality and morbidity. So the objective of that is to categorize into groups where you can count diseases and causes of death. In our classification here, we have fruits by color. So fruits, orange fruit, red fruits, and other fruits, because now we've learned that we need the other group. But what happened then if our apple this time is both red. What do we do now? Because we have categories for both. Maybe we had should it go into other or should it go into red? Because it is somewhat red. It's not completely red. So what do we do here? Well, in classifications, there are often associated conventions. So there's a range of rules that are included in a classification. And an example here is that if it's an apple and it's both red and green, then you should put it into red fruits. So in classifications in healthcare, you would often see that if it's a child, then you should use this group, this class, and if it's a male, you should use this class. So in classifications for healthcare, there will be not only those characteristics of a classification, but there will also be a range of conventions and rules. So here you have an example from the 2019 version of ICD-10, and you can see that it organized clinical data into these categories, or clinical codes into these categories. Chapter 1 is certain infectious and parasitic diseases. If you go down here to chapter 10, you can see that there's a category for diseases of the respiratory system. So if I asked you, where would you find a concept such as viral pneumonia? It's a pneumonia, so it's probably a disease of the respiratory system. But if it's a viral pneumonia, it could also go into the infectious and parasitic diseases. So just from looking at this, it's not easy to understand where to find a concept such as viral pneumonia. But the fact is that if you go into the diseases of the respiratory system, you can see here there's a range of subgroups. And again, if you go further down, this is similar to the ISA hierarchy, that it becomes more and more refined or detailed as you go in. But let us just look here, if I can give you an example where we see other. Did we do that? Yeah, down here in the first one, you can see there are other diseases of respiratory system, other diseases of pleura. That's a result of that principle that a classification should be exhaustive, that you should be able to categorize everything. So you'll see these other groups that will allow you to place everything. And the further down you get, you can see here that we end up with viral pneumonia and some specific types, and also other viral pneumonia. So you need to know your classifications when working with them. And I don't know if you have worked with the classifications before, but I bet that you know exactly where the codes that you are using fits in the classification. For reference terminology such as SNOMED, the design characteristics are different. We are also able to represent using a terminology fruits. And we also have maybe different types of fruits. And then each of the fruits will belong to not necessarily one category, but it can belong to multiple. So for example, the lime here could be both a citrus and a tropical fruit. And that's perfectly fine, because what the terminology tries to do is to say, what is this thing? And it is both a citrus fruit and a tropical fruit. So we don't make the decision of whether it's one or the other. We just try factually to represent what it is. Then we can have another branch or hierarchy in the terminology representing the colors. And we use these relationships to specify the defining properties. For example, we could have a defining relationship that was stating that it's a ripe color, and the ripe color of a grape or an orange would be orange. A ripe color of a lime would be green. A ripe color of banana would be yellow. So in terminologies like this, we have a polyhierarchy, not a monohierarchy. So we have multiple hierarchies, and we can allow multiple parents for a single concept. And we can allow the explicit specification of defining properties. And we have no residual categories. That means that we don't have the other concept. We don't have concepts for other things. which is also why SNOMED CT is so big. We try to represent everything that is relevant. So if something is missing, we add it. So SNOMED CT is an evolving terminology. So we release SNOMED CT, the international edition, every month. So with new additions that are required. And who specifies what is required? Well, users do. Here's an example of how the principles of a terminology is reflected in SNOMED, looking at viral pneumonia, bacterial pneumonia. And you can see the defining properties for viral pneumonia. And these concepts that are used in the definition are also SNOMED CT concepts sitting in other branches of or hierarchies of the terminology. And we're talking about actionability. And now it's been a long story about structuring data and why it's important. But let me now show why it's important for analytics at a high level. If we were using a classification such as ICD-10 to do analytics, and remember here how it looked in the hierarchy, well, then we could maybe want to answer some questions. We want to retrieve some information from our data. For example, we want to know if the patient have a respiratory disorder. And we've captured the ICD-10 code J12.9 viral pneumonia unspecified. So to this question, we could safely answer yes, because this code sits in chapter 10, and the code starts with J. So that sits in the chapter for respiratory diseases of this respiratory system. But if we wanted to know if the patient have an infection, we would say no, because those infections, they sit in the first chapter with the infectious and parasitic diseases. That's where you'll find the infections. And this starts with J. So we could say no to that, which would be incorrect. And then we could say, well, does the disorder affect the lung? Well, we don't really know because that's not explicitly declared in the classification. Is it caused by a virus? Again, there's no easy way to tell this. And you may think, well, we know that viral pneumonia, and there are also some written notes associated with it, but you have to remember that this is the computer trying to answer these questions. And if the information is documented in a textbook, it doesn't make it computer processable in that way. And that's why you need a terminology such as SNOMED, where you can answer the questions based on the defining properties. For example, in this case, we have captured the concept viral pneumonia, the disorder. And to answer the question, does the patient have a respiratory disease? We would know to say yes, because it's a subtype of respiratory disorder. If we want to know whether it was an infection, we could again say yes, because we know that it's also a subtype of infectious disease, because we have the polyhierarchy. We allow multiple parents. Does the disorder affect the lung? We could say yes, it does, because the finding site for this concept is the lung structure. And is it caused by a virus? Again, yes, because there is a causative agent, which is a virus. So all the concepts in SNOMED CT are defined with those defining properties, which will allow us to answer questions. And in this case, us is being the computers. So all of this background on SNOMED CT and this introduction will end with this slide on why we do this. So the point of departure are the patients who we want to provide the best options for care and treatment. Information is captured about these patients in the electronic health records. The data can be used for research and analysis, which again is the prerequisite to produce new clinical knowledge, new evidence, new enhanced knowledge for clinicians that can improve the way they treat and care about patients. But it can also foster the logic and knowledge required to develop decision support systems that again will contribute to the clinicians and will benefit the patients. And not only the patients, but whole populations, because the knowledge that is established can also help to specify policies and prevention initiatives nationally or for a larger population. So hopefully it will end up with the population not even becoming patients. So that's the introduction, and hopefully some motivation for why we need to care about terminologies and why we want to structure clinical information in the health records going forward. Are there any questions? If you're online, you can raise your hand, or you can add in your questions in the chat, and you're welcome to ask as well.